Mic check. So today we will be discussing about uh, one transistor array which is called as Darlington transistor array. Okay, it is called as Darlington transistor array. So there are so many variants even in Darlington transistor arrays. So today we will be discussing which is something called as ULN2003A. Okay, ULN2003A, which is nothing but a transistor array. So I will show you the images as well. So this is how ULN2003 transistor array look like. So it is basically an IC, integrated circuit. I mean, it's like a package. Within this package, there are several transistors which are known as no. Each transistor is connected with a flyback diode. Okay, I will show you the image as well, internal schematic diagram. So basically, this is called as ULN2003A Darlington transistor array, because internally there are so many transistors and each transistor is connected with a flyback diode. So I will tell you what's the role of this UN2003A. Usually yesterday we discussed about relay modules, right? Uh, in relay modules, we discussed the construction mechanism, how relays work, what's the construction procedure. Like it is made up of a coil, which is nothing but like an inductor coil, and then we are having normally open and normally closed pins. So along with that, we discussed the armature, which is the movable part. When a small electric field, whenever we apply small voltage to the pins of the uh, coil, then this small electric current produces magnetic field. This magnetic field causes the attractive force, and therefore the armature moves. And both are there would be two separate sheets, like a separate conductive material, which are placed very closely, so that whenever this armature moves, it touches the another part, and therefore the circuit is closed. That's what we discussed yesterday. And we discussed there are different types in relays, like a single pole, single throw, single pole, double throw, double pole, single throw, double pole, double throw. So like that, so many types are there in relays. So we discussed the working mechanism, and we discussed one more thing, how octocouplers or else octo-isolators do work, and how the mechanism is different from a relay and an optocoupler or opto-isolator. So in these are actually known as optocouplers because they are filled with an IR transmitter, that is IR LED, which can emit IR radiation, infrared radiation, and also a photodiode or phototransistor. Okay, so coupled with each other. So that's why it is known as optocouplers. And they can also use it to isolate two different circuits, two independent circuits. So therefore it is known as opto isolator. On one side we are having low voltage circuit, and on the another hand, on the another side we are having high voltage application, but still it can be controlled with the help of low voltage signal. Okay, this is what we discussed yesterday. So but uh, in practically, like if you just check the relay modules, okay, not I'm just not telling about the relay, actual relay, which is like a blue color having a mechanical frame. I'm not just directly talking about the relay. I'm talking about the module, relay module, where this relay is a component in that. So in that, usually, usually directly we do not connect the connections with the relay module. Okay, even the low voltage signal. So we usually do not directly connect it to, directly do not give the signal to the coil. Okay, if you are powering the relay module with just a voltage source like a battery, then you can power power it directly. Yeah. So if you are powering up a relay module directly with a voltage source like battery, then you can directly connect it to the coil, the coil pins. Okay. we are having two terminals for the coil, right, inside a relay. We can connect to that. But if we are trying to power up a relay module with microcontroller boards like ESP32 or Arduino or these kind of boards, then we should take even more safety protocols. Okay, we are not supposed to directly connect it to the relay module, because inside a relay we are having what? We are having a coil. Okay, so this coil having one property called as back EMF. Okay, so back EMF, so it can also induce an EMF towards the back side. Okay, so that's why we need to have something called as flyback protection. Okay, these are flyback protection. So the response, there is something called flyback diode. Okay, flyback diode. The responsibility of this flyback diode is to clamp the current spikes which are coming in the opposite direction to the ground. So that's why we use these kind of ULN2003A Darlington transistor array. In this package we are having transistors. Each pin is connected with a transistor, and each Darlington transistor is connected with a flyback diode. So on one side we will be giving low voltage input, and on the another leg is connected with the relay module. And again relay module can be connected, module on one side we are connecting it to this ULN2003A, and on the another side you can connect it to something like a light source, or else a bulb or any load which will be operating at higher voltages like a 220 volts, something like that. So Ibrahim, you are able to understand? You are actually, I think you missed yesterday's session, isn't it? Ibrahim, are you there? Yeah. So you are you able to understand like what we are discussing about today's session? I think you may not be able to understand because you have not attended the yesterday's session, right? Yesterday we discussed something like a relay module. Okay. So I will show you that. So yesterday we discussed about the construction of a relay module. How what's actually inside the relay. See, you might have seen these kind of modules, right? These are actually called as relay modules. Okay. So basically these are actually called as relay modules. So yesterday we discussed how these relay modules are constructed. So the construction, working mechanism, and we discussed about types of relay modules. There are different types like single pole, single throw, single pole, double throw, double pole, single throw, double pole, double throw. So like this we are having 4 different types. And we discussed about the parts of a relay like the armature, the internal coil. See, this is how a relay module would look like. Okay, this is how a relay module would look like. Yeah, so if you just open this mechanical frame, you will find something like this a coil. Okay, and these two terminals belong to this coil. Okay, so inside a relay module, if you just open the mechanical frame, you will find a coil. So this upper part is the movable region. We call it as the armature. Whenever you apply small electric field to these coil pins, this armature move. Okay, and if you just check, both these sheets are placed very close to each other. So it causes a it closes the circuit. Okay, so basically relays are used if you want to control, like if you want to switch on and off a high voltage application, like if you want to turn on and off something like a 220 volt with the help of 5 volt. Okay, so with the help of 5 volt you can turn on and off a high powered application, but both these circuits are independent with each other, like they are not connected with each other. So these low voltage circuit is independent and the high voltage circuit is independent, but still with just a small applying a small low voltage, you can turn on and off the you can control, you can switch between on and off of high voltage applications. So for that relay module is used. Okay, in this relay module we are having different types like single pole single throw, single pole double throw, double pole single throw, double pole double throw. Okay, like this we are having four types in relay modules. That's what we discussed yesterday, and along with this we discussed one more thing. Just like how these relay modules function, similarly we are having one more thing called as optocouplers or opto isolators. Okay, so these optocouplers or opto isolators are little bit advanced than the relay module. Okay, so the relay modules basically work with the help of electromagnetic principle, electromagnetism. When you apply the electric field to this coil, this coil produces a magnetic field. Due to that magnetic field, these armature moves. So these both things are placed very close with each other, such that whenever the magnetic field is produced around the coil, these sheets that touch with each other, and then it forms a conductive region. So basically on this side to the, see, you are applying a DC voltage to the coil, but these armature is having at a higher voltage. Okay, at a higher something like a 220 volt or 120, something like that, higher voltages. So that means with the application of, but actually you just need to observe one thing, like this higher voltage and lower voltages are not connected with each other, both are independent, because you are applying a low voltage to the coil, and this coil produces the magnetic field. Due to that magnetic field, this armature moves, and due to whenever armature moves and touch with each other, it forms a closed circuit for the higher voltage. So that means the magnetic field is playing an important role, but it doesn't mean that both circuits are connected with each other, both are independent. Okay, similarly there is one more component called optocoupler or optoisolator. That's what we discussed. So today we are discussing about Darlington transistor array. Okay, we are discussing about Darlington transistor array. So up to here everything is clear, Ibrahim? Up to here everything is clear, the construction of a relay and why it is used. Yeah, it is used to control a high voltage application with a low voltage, but both are independent with each other, both are not connected. So then how it is working? With the help of the magnetism. Whenever you apply electric field, magnetic field is produced around the coil. Due to this magnetic field, the close the closed surfaces touch each other. Whenever armature move, due to this magnetism, it attracts them, and therefore it forms a conductive path for the higher voltage. That's how you are conducting. That's how the working mechanism of a relay. Okay, similarly the principle is different for optocoupler or opto isolator, that we will discuss. Okay, you actually missed that. So now we what we are discussing is actually called as a Darlington transistor array. So earlier I told that if you just apply a small voltage to a relay module, you can operate a high voltage application, right? But now what I'm just telling you is, if you are directly applying the small voltage with the help of a battery or any voltage source, okay, then it's fine. You can control high voltage application. But if you are trying to operate a higher voltage application from, by connecting it with something like Arduino module or ESP32, they also provide low voltages, right? Those modules are also run at lower voltages, but still it is not safest to practice to directly connect the these two pins, okay, the coil pins, okay, these two coil pins directly to the Arduino or ESP or any other microcontrollers which are operating at lower voltages. The reason is that these coil can induce back EMF. Okay, so that means due to about the induction principle, so this can induce a back EMF. Okay, to reduce that back EMF, this Darlington transistor array is used. Okay, I'll show you. See, this is the image of the Darlington ULN2003A transistor array. Okay, if you just want to see the appearance of that component, this is how that component look like. Okay, so if you want to connect a relay with something like a battery, you can directly connect it. But if you want to connect it to something like Arduino module or Arduino Uno or ESP32, ESP8266, then to connect with any microcontroller architectures, then you need to use this particular component. Okay, because it is the safest practice. Okay, it is the safest method. So why it is used? If you just check out this image, okay, I'll show you that image. So if you just check out this image, so usually instead of directly applying the low voltage at this coil pin, So what you are doing is you are connecting this relay with one side of the this ULN2003A transistor array component. So one side you are connecting the relay, and on the another side you are applying the low voltage. Instead of directly applying the low voltage from the microcontroller with the relay, you are applying it on the one side of the this particular component, and on the another side the same voltage is passed to the relay. So why we need to use this particular thing in between? The reason is that here we are having something. You're seeing a diode, right? So this is actually called as flyback diode. Okay, this is called as flyback diode. And these we can also find some transistors. Okay, so these transistors are called as actually Darlington transistor. Okay, inside we are having Darlington transistor and along with a flyback diode. So this flyback diode protects from back EMF. So if you are passing a current from this direction, it is allowed. Okay, but inside a relay we are having a coil, right? So the coil has the property like it can also push the current from this particular direction. So it is not allowed because microcontrollers are they are having low sync current. Okay, like it can accept only, even if it is in the reverse direction, it can accept something like only 20 milliamps. That is the maximum. Okay, but here if we are using the relay, there's a chance, there probability like we are getting something like 500 milliamps. So if you pass 500 milliamps current in the opposite direction to a microcontroller board, then it will damage the IC, integrated circuit, the main microcontroller of the board. So if the main microcontroller IC is damaged, then the entire board is waste, right? So we need to protect the board from the flyback current. So flyback current means it is coming in the reverse direction. So this particular diode, flyback diode, is responsible for it. Whenever the current is coming in the opposite direction, so it clamps the current into the ground. Okay, so the opposite current surge is clamped to the ground. That means it is discharged to the ground, which is the least conductive, least resistive region. It's a highly conductive, it's a least resistive region, and therefore it will protect the main microcontroller that we are using. So the main intention of using this
Here is another.
ULN2003A Darlington transistor array is to suppress it is internally coupled with Darlington transistors, which are coupled with flyback diodes. So the main intention objective is to suppress the flyback current, the opposite current surge, okay, which is called as flyback current, should be clamped with the ground. Okay, it should be discharged to the ground. So thus we are protecting the main microcontroller from the current which is getting in the opposite reverse direction or reverse current, and therefore the board is protected. So this particular component is used to protect the board. So if you know how to use a relay module with a battery, and if you just blindly connect it to a microcontroller in the same way, so there is a probability for the main microcontroller to get damaged. The reason is that you are not thinking about the flyback current, the reverse current. Okay, so that's why it is very essential to follow all safety practices and standards. So therefore ULN2003A is used to protect from the reverse current surge. Is that clear? Just respond with the thumb so that I can understand. Is that clear, Ibrahim? Why we use ULN 2003? Why not directly connect a microcontroller with a relay module? We use this ULN 2003 in between a relay and the main microcontroller. The reason is to protect the microcontroller from the reverse surge current. Okay, so if there are high reverse current, the microcontroller cannot handle it. Okay, it is having low, it can accept the reverse current as well, but it is very low. It can accept only very little bit amount of reverse current. But if you are providing something like 500 milliamps of reverse surge, reverse current, it cannot handle it. It will damage the IC. Okay, whenever any such reverse current is there, immediately this ULN 2003A will come into the picture. It will clamp the high current from being entered into the main microcontroller pins. It will clamp it to, instead of the current flowing through towards the GPIO pins, general purpose input output, it will clamp that current directly to the ground. Okay, that current will be now discharged into the ground. Thereby it is protecting the main microcontroller. So that is the main reason why we are using ULN 200A. Okay, 20. Yeah. Now we will check the data sheet as well. So today we are having, I think you are there in the PCB class as well, right? Today we are having one more interesting concept in PCB design tonight. So that is about fingers, gold fingers. So you might have seen something like these are actually called as gold fingers. Okay, these gold fingers are there in something like a graphic cards, isn't it? Graphic cards, network cards. So for that we will use golden fingers. We will discuss that session. Just join tonight at something like 7:15 p.m. IST. I think your time is something like, if you are in Nigeria, it is something like 5 hours 30 minutes less, I think so, or somewhat like that. I don't know exactly what time zone. So it's 7:15 p.m. IST. We will be having a session on golden fingers in PCB. So I hope today's session is clear. It is very short session. So just to understand, yesterday we discussed about the construction, working mechanism, like how it works, and optocouplers and opto isolators, and then types of relays, single pole, single throw, single pole, double throw, double pole, single throw, double pole, double throw. And today, why not directly connect the relay modules with ESPs and other microcontrollers? We need to have a protection, the component which is protecting the diodes, I mean the microcontrollers from the reverse surge current which is coming from the coil, internal coil of a real relay module, is Darlington transistor array. So it is called array because it is containing so many transistors inside the package. Okay, inside a single package there are so many transistors. So that's why this is called as a Darlington transistor array. Okay, if you want to check the data sheet, I will show you the data sheet as well. See, this is what the description provided in the data sheet. ULN2003A is a single chip integrated high voltage, high current Darlington transistor array which contains 7 independent Darlington transistor driving circuits internally. See, this is the main thing. Flyback diode is designed inside the circuit which can be used to drive inductive loads, okay, such as relays. Relays are inductive loads. Why? Because it is containing a coil. A coil is on another, it's something like it's just something like an inductor. Okay, whatever any component is having a coil, they are considered as inductive loads. Other than coils, rest all are considered as resistive loads. Of course, they are having some all these three properties: resistance, capacitance, and inductance. But mostly we call them as the resistive circuits. Okay, so anything which is having which containing a coil inside that internally is called as an inductive load. So we should not directly connect an inductive load directly to a microcontroller because they are highly sensitive. Even a small reverse surge current can damage the main microcontroller IC. So to protect from the reverse surge current, see, this is what the 500 milliamps. Okay, it can collect up to this ULN2003A can correct. It can act as like a sink. Okay, for 500 up to 500 milliamps of reverse surge current, reverse current. So you can go to these specification as well. These are, see, total we are having 7. Okay, 1 2 3 4 5 6 7, 7 independent. Okay, with this pin you can control one relay, with this particular pin you can control another relay, like that. With 7 pins you can control 7 relays. Okay, yeah. So you can connect these 7 pins to safely. Now just no need to worry about anything because already internally you are having a current sink. Darlington transistors are there. You are having flyback diodes. So no need to worry. Now these 7 pins can be connected to 7 GPIOs of Arduino Uno. And with that 7 pins you can control these 7. These 7 pins are connected to a relay module, and if you just toggle the state from on and high and low of these 7 GPIO pins, so accordingly those relays will also function. So that relay can control the high voltage. okay, something like a bulb which is connected to 220 volt, that can be turned on and off. If you just simply toggle the state from high to low or else low to high, just by toggling the state of the pin, uh, GPIO pins of the microcontroller, you can control the high voltage application. Yeah, that's today's session. I hope everything is clear. If you have any questions, you can post in the chat box, else I will end the session. Yeah, so thank you for joining today's session. So today we discussed about ULN2003A Darlington transistor array, which is used to protect the main microcontroller from being damaged by the reverse flyback current. Okay, reverse current, and it acts like a sink. Okay, sink for current up to 500 milliamps. It is having flyback diodes which can suppress the reverse current and then can directly clamp the reverse current into the ground, discharge the current into the ground, so that you can safely operate relay modules with any microcontrollers. So by default, without these flyback diodes, you cannot directly connect an inductive load with a microcontroller. Okay, because if you connect an inductive load, it will also induce a reverse current, due to which the microcontroller get damaged. So I hope today's session is clear. This is your expert mentor, Hemant from Suchana, signing off. Bye bye.